This is electrical testing, Mech 14. The instructions here say draw a diagram showing the proper way to connect the following meters in a simple series circuit with a switch and a light bulbs. And so I'm going to draw those. First one we're going to do is ammeter. So I'll just zoom in here a little bit and we're going to do ammeter. We always have 5 elements of our circuit. First thing we need is power source. Usually off that power source we go around and we're going to attach that to a ground. We'll come up. The next thing we need is circuit protection, and that's a fuse. After that we're going to draw a simple switch, single pole, single throw switch. After that we're going to go down to a simple light bulb, and then we're just going to draw a ground, and that means that this ground and this ground are attached. So I'm going to erase that and just we're going to assume that that's true. Good, so this is a simple series circuit. How do we hook up an ammeter to it? Ammeter measures amps, and amps means flow. And so the way that we can measure flow through a circuit is to get in the way of the circuit. So what we would have to do is we would have to remove, back there, we're going to have to remove part of the circuit. So we would disconnect the wire from this area here. Now I'm just going to draw an ohmmeter, and I'm going to say that it's set on amps. We've got one lead here and one lead here, and so we're going to string those leads over, and I'm going to connect that one to that side and that one to that side. That way current will flow from the positive battery cable through the fuse. We turn the switch on, it'll go across through the switch, and then it has to go diverted all the way down to the ammeter, through to the bulb, back to the ground. The bulb will light up, and the ammeter will measure a certain number of amps for there. Certain number of amps. We're measuring the flow, therefore current has to flow through the meter in order to get to the other side. There's also another way to measure amps, and that way is with something called an amp clamp. Now typically an amp clamp has a couple wires coming off. We're going to just join these together, and when these come out we can take this amp clamp, and an amp clamp is just a circular thing with an opening, and it's got a handle on it and like that, and then it measures the amount of current flowing through the circuit by measuring the strength of the magnetic field around the circuit. Remember that whenever current is flowing through the circuit, there's a magnetic field around that circuit. So if it's a stronger magnetic field, then the meter reads a higher amperage. Again, with the voltmeter, we're going to draw all the parts of a circuit. This is good practice. We've got the positive and the negative of the power source. Current flows would flow up to fuse, through a switch, down through a light bulb, and down to a ground. The light bulb is the load. To measure with a voltmeter, we measure in parallel, as opposed to the ammeter, we're measuring in series. In other words, current flows through the meter. Voltmeter is parallel. So we'll just draw our voltmeter in here. We'll take one lead and we'll attach it to there, and then we could take the other lead and just attach it to the other side there, and then we would measure the value of the voltage, or the difference in voltage in the battery. If it's a 12 volt battery and it's fully charged, it'll say something like 12.6 volts. We could do this at any point. We could also take the leads and we could run it, and I could go on this side of the bulb, and then I could run it over to this side of the bulb. So it goes in 2 different places. Here's this part right here. Just runs over that way. And so I'm measuring the voltage drop of this bulb. I'm measuring how much voltage is used in that bulb. If there's more than one bulb, it shares the voltage. but in this case it'll read 12.6. The last part is the ohm meter. And so again, I'm going to draw our circuit. Positive, negative, over to ground. We go through a fuse, through a switch, quickly down through the bulb to a ground. We've got our ohm meter here. It's going to read in ohms. It's going on an ohm setting. Now we take a lead, and whenever we use an ohm meter, we have to disconnect power. So right now you can see on this side of the switch, it's disconnected already because the switch isn't on. Current is not flowing. If we hook up the ohm meter and then turn current on, current flows through the meter and it damages the meter. The way that the ohm meter works is that you use a certain amount of current in the ohm meter and it sends it through the circuit, and then it measures how much comes back. In order to do this, we're going to disconnect. So one of the things we might check is the light bulb. And so we'll just take this lead, and I'm going to go over here, and I'm going to take this lead, and I'm going to go to this side. So I'm measuring the amount of resistance in this bulb right here. I'm measuring the resistance. In a bulb, it'll be something like 0.36 or something like that ohms. In a wire, because we could take this lead and we could go over here, and we could take this lead and run this one over here. And in that case, we're just checking this wire right here. In that case, this wire isn't much. In fact, it should be 0.001 ohms or something like that. And that way we can check the wire, because if it is broken, then current can't flow through it. And if current can't flow through it, then it's going to have a reading on our meters of OFL. In other words, zero flow. Current cannot flow because it's broken.